Welcome back, everyone. This week we are starting statistics and probability. So I'm going to do more of the instruction type stuff this week, and then next week you're going to have a project to work on. So when we talk about probability, we are referring to how likely is something to happen. So if there's a 40% chance of snow, what does that actually mean? And so there's three different ways we can write probability. We can say it as a percentage. We can put it as a fraction, which is often where the experimental data actually comes from, or we can convert that fraction into a decimal. When we talk about theoretical probability, this is what we think should happen without actually doing any experiments to test it. So if we think about flipping a coin, we think that there should be the same probability that it lands on either side. Therefore, if there's two options and both of them are the same, one option, so one out of those two, let's say tails, well, 1 over 2, that's the same as 0.5. We could also call that 50%. So that's where probability, theoretical probability comes from, is we haven't actually done any of these experiments, but this is what we think should happen. Experimental probability is, okay, now we have actually flipped the coin, and what did we notice? So when we say 7 out of 10 times, we can think of that as our fraction. So we can think 7 over 10. If you go 7 divided by 10, you end up with 0.7. So we're saying that that is the experimental probability, because that's what happened when we did the experiment. Now that doesn't sound quite right. We would think if you do it 10 times, it should be 5 heads, 5 tails. But probability doesn't always work out exactly the same. So one of the ways we can get more accurate experimental probabilities is by redoing this experiment more times. So maybe instead of 10 times, we do it 100 times. Because if we do it 100, we're probably not going to end up with 70 and 30. That'll probably bring it closer to a 50-50 split. And if we do it, say, 1,000 times, it's definitely not going to be 700 and 300. So that's one way you can improve your experimental probability. But if you didn't do that, if we did the 10 coin flips, and let's say there is this freak chance that all 10 of them came up as tails, you could make what's called a subjective judgment about that. So basically you were looking at something and saying, like, you're putting your own opinion onto it. Kind of like how you feel about that. If I flipped a coin and 10 times in a row it was tails, you might think like, okay, where did you get this coin? Has this been weighted differently so that it lands on tails all the time? And then if you did the experiment up to 100 times or up to 1,000, and you notice that same pattern, well, then your subjective judgment would probably be correct, and there isn't actually an even chance of both sides. But with a small set of data, with only 10 flips, it's not always very accurate to make those subjective judgments. So if we want to think about what is the probability of rolling a 4 on a standard 6-sided die, well, when I say standard, I mean it's not weighted or anything like that. So if I want to know the probability of rolling a 4, I need to think about the outcome that I'm looking for. So how many different ways are there to roll a 4? There's only one way. To get probability, we are going to divide by the total number of outcomes. And if you look at a standard 6-sided die, there are 6 possibilities, so 6 different outcomes. That means that the probability of rolling a 4 is 1 out of 6. And you could convert that to a decimal. For right now, let's just work with fractions. Next, I want to know the probability of an even number. So if I'm thinking still about my outcomes over the total number of possibilities is still 6. There's still 6 things that could happen, so it's still going to be over 6. But the outcomes I'm actually interested in, well, now I could roll a 2 or a 4 or a 6. So whereas the last time I was only interested in this one outcome, now I have 3 different outcomes that I'm interested in. So my probability is 3 over 6, which we could simplify to be 1 over 2, and then we could also put that into a decimal. Next, if I want to know the probability of getting a king out of a standard deck of cards, in a deck of cards you have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then there's a jack, and then there's a queen, and then there's a king. So there's 13 different cards, but there's also 4 different suits. 2 of them are black, 2 of them are red, and each of those 4 suits has all 13 of your cards. So you end up with a deck that has 52 cards in it. Of those 52 cards, I told you that there's 4 suits, and each suit has 1 king, so there are 4 kings. So if I want to talk about the outcome that I'm looking for, and this will be the last time I write this one down because it's kind of a pain trying to write with my laptop here. But if we're talking about the outcomes we're interested in, divided by total outcomes, I have 4 different kings that I'm interested in pulling. So my outcomes would be 4. And in that deck, there are 52 cards. So my probability is 4 out of 52, which I could simplify as 1 over 13. If I want to get a heart, so there are still 52 cards in the deck, but now I gotta count how many hearts are there. So there's ace, 2, 3, 4, all the way up to 10, so that's 10. And then there's jack is 11, queen is 12, king is 13. So if I want to do the outcomes I'm interested in over the total outcomes, there are 13 I'm interested in, 52 cards in total, and I can simplify that to be 1 over 4. Okay, if I want an odd number on a 6-sided die, there are 3 different odd numbers that I could roll, and there are 6 numbers in total. So that works out to be the same as the probability of an even number, which kind of makes sense because those are equally likely to happen. If you want a prime number, let's write out the numbers that we could possibly roll. And we're going to have to review, what does a prime number actually mean? When we say prime number, we think that it has 2 factors. It has to have exactly 2. One of them is itself, and the other is 1. So if I look at a number like, let's say 6, 6 is not a prime number because it has factors of 1, 2, 3, and 6. So if you went 1 times 6, that would be 6. If you went 2 times 3, that would be 6. 6 is not a prime number, so we're going to put an X through that one. 5 only has factors of 1 and 5. So 5 is a prime number. 4 is not, because you have 1, 2, and 4. Those are all factors of 4. So that's not a prime number. 3 is because we only have 1 and 3. 2 is because we only have 1 and 2. And 1 is actually not a prime number because the only factor is 1. And to be a prime factor, you have to have 2 factors. So we have 3 outcomes we are interested in. There are 6 in total. So the probability would be 3 over 6, or simplify that, 1 over 2. And if I did ask you for a decimal, you could tell me 0.5. If I asked you to give me a percent, you multiply that by 100%, and you get 50%. If we want to know, so going back to our deck of cards, what are the chances you pull out a red card? So there are 13 hearts in a deck that are red. There are 13 diamonds in a deck that are red. And then clubs and spades are both black. So 13 plus 13, that gives us 26 cards in total that we're interested in. And there's 52 cards in the deck. So we get, if we simplify that, probability is 1/2. Kind of makes sense then that if I were to count the probability of the black cards, it would also be 1/2, meaning there's also 26 cards in total, 13 clubs, 13 spades. If I'm only interested in the ace of spades, so there's 4 aces in a deck, but 3 of them are clubs, diamonds, and hearts, and I'm only interested in the ace of spades, that is only 1 card. But there are still 52 cards in the deck, so we can't simplify that. That is going to be the probability of pulling the ace of spades. Okay, here are some practice questions for you to work on, and then we'll get into the next topic.